We're going to go ahead and do electrical safety testing on this ForceTriad ESU utilizing the Pronk Safety Sim Safety Analyzer. We need to get the unit ready to do the testing per the manufacturer's requirements that are in the service manual, and we're going to do that via the Pronk Mobilize app. This app is available on the App Store, and you can search for it and download it by searching for Pronk Mobilize. So you download the app, and once you do download it, we need to first go to the Setup menu so that we can connect our devices to the unit. So I'll demonstrate that for you here. You go to Device Connections, Locate Safety Sim, tap on this blue bar here where you can identify the safety sim you want to pair, and you'll see the available devices here below, and you would select the ID that corresponds to the serial number on the back of your unit. That's the device you would select to pair to your app. You'll know you're paired because the green light comes on here letting you know that you're paired and connected to the app, and you stay paired to it until you choose to unpair or close the app. As a quick side note, at the top here are header information that you want to edit and customize, as this information gets added to electronic service report that gets generated automatically at the end of our safety test here. So we want to go ahead and run that and have that customized. Once that is set up, we want to go ahead and set up our electrical safety test, and we do that through the Edit Device Types. Here, once you're here, you want to go to Customize ST Profiles, and then here you will see your library of electrical safety sequences we have made. If you want to add another one, you can simply tap on New to add another safety auto sequence. In our case, we've already created the ESU ForceTriad, but let's go through it in detail to understand what testing we need to perform per the manufacturer's requirements. Once you go to the Edit screen, you'll see at the very top here, you can name the name of the auto sequence or the profile. We've already created a name here for it, so we can easily identify it in our library to run the right test. And the next field down is DUT on time, which is how long do you want each test to run before it advances to the next test. The default is 2 seconds, but we've set it to 30 seconds because this unit has an extended boot up time. We want to make sure we allow it enough time to turn on. The next field is DUT on-off repeat, which is, do you want to repeat the electrical safety testing twice on the unit, once with it off and again with it on? In our case, we only need to do it once with the unit on, so we'll leave this unchecked. The next field is DUT power at end, which is, do you want the ESU to stay powered on at the end of the safety test so that we can do functional tests? I always suggest enabling that and having that checkbox on. Sim auto sequence is for simulation auto sequence. Of course, we don't need to do that, so we'll leave that as off and none. The next test is ground resistance test, or the ground bonding test as it may be referred to. We've set the limit per the manufacturer's requirements to 300 milliohms. And below that are the electrical safety test sequences we can perform. You have a choice of running a variety of earth leakage tests, chassis or enclosure leakage test, a lead leakage to grounds test, or a lead leakage source test, as may be referred to, or a lead leakage sink test, which is also commonly known as a lead leakage ISO or a lead leakage main and applied parts test. Per the manual, we could either run a chassis leakage test or an earth leakage test. We're going to go ahead and program it to do a chassis leakage test or an enclosure leakage test. Once we've selected that, we need to do it in normal conditions, which is with the ground closed, the neutral closed, in normal polarity. We're not going to run it in reverse polarity. And we've set the limit to 300 microamps, which is what's stated in the service manual. The next test we need to do is a second chassis leakage test, but this time with the neutral open. That's why you see open here. Normal polarity again, no reverse polarity, and the limit for this test is 1,000 microamps. The third test down is a lead leakage to grounds test. And we need to do this in normal conditions, and we need to have the limit set at 10 microamps, which we've done here. And then the next one is a second leads to grounds test, or a lead leakage source test with the ground open, neutral closed, and the limit for this test is 50 microamps. Then the very last test is that lead leakage ISO, or lead leakage main and applied parts test, where we're taking 120 volts AC and applying it to all of the leads or applied parts, or in this case all of the outputs. It's also referred to, so we're taking 120 volts AC and putting it on all those applied parts. Just know it is current limited. There is a 120 k ohm resistor limiting the current for safety protection, but you're still energizing that high voltage, so you want to be careful and make sure you don't touch those leads. We're going to do this with the neutral closed in normal polarity, and the limit here is also 50 microamps. So we've made sure we configure our test the way we need to, and we can save this, and it will get saved into our library of available procedures you can utilize on the app. So now you back out to the main menu, and you want to now select safety only mode. You want to tap on app profiles, and you'll see your list of all your profiles you've created on the app, and you can scroll through them and select whatever test you want to. In our case, we need to select the ESU ForceTriad, and it's also the same test for the FT10. So now we have our test configured. Now we want to make sure to set up the unit properly. We want to do that by connecting the ESU to the left side of the safety analyzer. You have the red test lead cable that connects to the back of the unit to the ground post. And then we need to connect all of the outputs to the lead section of the safety analyzer for doing our applied parts or outputs tests. So you want to use these banana plug adapters connected to each output. And you want to do that for the monopolar one by connecting it to the very left side and then to the right side. You also want to connect your UFP using this special adapter to do that test, which you can then connect a banana plug to it and plug that in there. And then we also want to do the same banana plug connections for monopolar 2, left side and right side. Same for the third port over here on the right and the lower one as well. And then you have your bipolar port. You're going to do the same thing, connecting it to the far left and to the far right. We also want to connect our REM connections to the safety analyzer using these alligator clips to connect to it so we can connect them to the safety analyzer. To connect them to the safety analyzer, you want to connect them to the upper section, the ECG snap section, and you're going to take the banana plugs of each one and just slide it under each one of the snaps here. Doesn't matter what snap you're connecting it to. There's no particular order you need to do it in. So you're able to connect all 10 wires to it. In our case, we have extra wires to connect to, but utilizing these dual plug banana plugs, I can daisy chain them into each other so I can be sure to connect all of my applied parts to the safety analyzer simultaneously. So now we've got it all configured. We're ready to do our test. So I want to go to the app here and enter in an asset ID. I can do that manually by typing in, clicking on this field here to open up the keyboard to enter in an ID. Or if I have a barcode on my devices, I can hit the scan function, hold it up to the medical device, scan that barcode so I can accurately capture that information into the report. So now we go ahead and we've selected our test and you hit start. The safety analyzer will automatically start to perform that test, and we'll see here in the lower window via the Mobilize app that we're running a ground resistance test, and we're going to start all the other tests. So we've turned on the ESU analyzer. It's going to take some time to boot up. That's why these tests will take a little longer to run, giving the analyzer time to boot up so we can do this test. So in this lower window here, you'll see the name of the test. We're doing a normal polarity chassis leakage test in normal conditions. Below that is the measured leakage that we're measuring. And then below that is how much current the device under test is drawing. So you can see as it's booting up, the current draw is ramping up as well. So it's going to go ahead and do all of those tests as we're running through it. Now, when we're running our electrical safety tests, you could very well see this message on the screen. It's an error message that comes up because we've kind of connected all these to the safety analyzer, so it thinks we've activated the touchscreen or the foot pedal. This is normal. It's not an error with the analyzer. It's normal because we're doing the electrical safety test, so it will not impact our electrical safety measurements that we make if you see this message on the screen here. So you could just continue to do the test. So again, you can see on the safety analyzer here, on the Mobilize app, it's doing the testing necessary. We're now doing a lead leakage to ground test with open ground, and it's getting that measured value here. So as it's doing each individual test, the information is coming back, being captured, so that it can be captured all in the electronic report, which we'll see at the end of the test. So it's important to make sure we're following the manufacturer's procedure. That's why it's helpful to have it programmed into the app so that there's consistency in what tests are being performed and all that leakage measurements that need to be captured. So when we get to the leads ISO test, or as I mentioned, the leads MAP test, the main unapplied parts, it's putting 120 volts AC. So this is an indicator of the analyzer letting you know do not touch those leads, because even though they are current limited, you still have mains AC voltage on there at 120 volts AC. It's actually 10% above mains voltage, and so we don't want to touch those leads. So it's going to run that test, and this is just a safety precaution letting you know that those leads are hot. Once it's done, it's going to go on to the next test, which is performing a chassis leakage with the neutral open. So once you do the neutral open test, the analyzer will power off. That's normal because we're doing a fault condition when we're simulating that the neutral line is open and doing a chassis leakage test under those conditions, and that's why you see the unit turning off. But we're getting very low leakage in that situation, but nonetheless, that's a requirement of the manufacturer to perform that test. We have to make sure we perform it as well. So it's going to do all of this tests automatically, so we can capture all those results. And once it is done, you'll get to a test screen here, a review screen, where you can see all of the information, all of the testing that we performed, including that header information I mentioned earlier, the test equipment we used, the date it was calibrated, and then all of the testing we did for electrical safety are listed down below. And in the center here are your measured values. Over to the right are your test limits per the manufacturer's requirements. We've completed this test. It passed. The app will indicate everything passed. If anything failed, the app would show fail here. And the same thing on the safety analyzer itself. You can see the safety analyzer is glowing green, letting you know every test passed. If anything failed, the analyzer would also be red. So we've completed the test for this ForceTriad device.